Bismillahirrahmanirrahim. Assalamu alaikum, dear students. My name is Ali. I am your physics teacher, and in today's lecture, we are going to discuss a topic of physics of 10th class, chapter 12, geometric optics. And the topic of discussion is image location by convex lens. We will discuss that in convex lens, when object is placed at different positions, how image is formed, what is the nature of image, what is the location or distance of image from the lens. Students, first case where the object is placed, and we will check the nature of image, that when object is placed beyond 2f, means if we place the object at a distance of more than 2f, more than double focal length of the convex lens, then where image will be formed and what will be the nature of image. Students, you can see in the diagram that if object is placed beyond 2f, the rays, two principal rays, the ray parallel to principal axis and the ray passing through the center of lens, will meet on the other side, on the right side of the lens, between f and 2f, means between focal length and double focal length, distance of double focal length. And students, you can see the image is inverted with respect to the object. It is smaller in size and it is real. How it is real? Because rays actually meet at this point, and where the rays actually meet to form the image is called a real image, and where the rays just seems to meet but not actually meeting there, the image is called virtual image. So we can say that when object is placed beyond 2f, then image will be found between f and 2f. It will be inverted, it will be smaller than object, and it will be the real image. Student, before discussing the next position of object, I am going to tell you the sequence, that when we will bring the object closer to the lens, the rays will diverge more than before, and the rays will meet at more distance than before. So we can say that distance of image will increase as the distance of object will decrease from the lens. And secondly, if the image comes closer to the lens, the size of object comes closer to the lens, the size of image also increases. You will be clear by discussing the next case. Students, the next case is when object is placed at 2f, with the distance of double focal length. When object is placed at 2f, the rays, two basic rays, after passing through the lens and refraction, they will meet at a point at exactly 2f, and we can see that the height of object or size of object is equal to the size of image, and we can also see that the distance of image is increased than before. So we can say that when object is placed at 2f, image is formed at 2f, image is real, image is inverted and equal in size. So a question can be asked, then when the distance of object and image and height of object and image is same, the answer will be when object is placed at 2f, then height of image and object and distance of image and object from the lens will be equal. So in the next case, we will bring the object more closer to the lens. It will be between f and 2f, and rays will diverge more than before, and they will meet beyond 2f on the other side. We can see that the distance of image is increased than the earlier case, and the size of image is also increased. So we can say that where the real magnification occurs, we can say when object is placed between f and 2f, then the image will be magnified and real. So when object is placed between f and 2f, image is found beyond 2f, image is real, inverted and magnified. So in the next case, we will bring the object at the distance of exactly f. We can see that after passing through the lens, the rays will diverge like way that they will become parallel after refraction, and the rays parallel to each other will meet at infinity. So we can say that no image will be formed. So the case when no image will be formed in case of convex lens, it is only then when object is placed at f, the rays become parallel to each other and no image will be formed in this case. So let's say the next case, when you bring object more closer to the lens between focal point and center of the lens, the rays will diverge away from each other, and they seems to come from a point, or they seems to meet at a point behind the object. They will not actually meet at this point, they will seems to meet, and the image can be seen. This image will not be real. I've already told in the previous lecture that when rays actually meet, the image is called real image, and when rays seems to meet at a point to form an image, it is called virtual. So this image is, we can see that erect, it is magnified, and it is virtual. So the nature of image when the object is placed between f and center of lens, it will be virtual, it will be magnified or larger, and it will be erect. So question can be asked that when the image will be erect in case of convex lens, and it will be virtual. So answer will be when object is placed between f and center of lens, then image will be virtual, and image will be erect and larger in size than the object. So this was the last case which we have discussed. Hopefully the concepts are clear.